You've probably heard this a million times before, but to solve maximum subarray, you need to employ a variant of Kidane's algorithm, written by this guy. It does the job pretty efficiently, but if you're a woke free thinker like me, you may also be a bit sus and have some questions. When do we include negative numbers in the subarray? When do we discard the subarray and start fresh? And lastly, it may not seem very intuitive at first, so why does this algorithm even work? Now, I can't be asked to give you all a proof about this, but I can draw some pretty pictures and animations to explain it. Imagine I'm going to South Asia to find myself, and I decide to go on a series of hikes. Every array value represents a mountain elevation, and I want to find a sequence of elevations that gives me the highest total elevation gained in a row. So I start climbing, and at the end of each climb, I have a choice. Either I can record this hike and add it to my Poppin, Strava, Garmin, Fitbit social media thing, aka my current array sum, or I can reset and start fresh from zero. Keep in mind, my overall objective is to find the highest elevation gained in a row. So I don't know if 2 is actually going to help me reach my highest overall elevation, but it's better than nothing and it's helping me raise my altitude and get off the ground, so might as well add it for now. And that brings us to the overall methodology as to how we're going to approach this problem. As long as your current sum is greater than 0, might as well just keep on adding everything and move on. The moment you hit anything less than 0, might as well discard everything and start fresh. If you hit -4 or even -1, whether your next value is 3 or 1 billion, by adding a negative value, we are reducing our output. Might as well reset our car sum to 0 and start fresh from 3. Eventually, we reach the end and have our overall max sum because we've been storing it in a max variable this whole time. That's how you solve maximum subarray efficiently. Space complexity is constant, time complexity is O of n, and the common gotchas for this problem are the following. Make sure you're doing this curmax check at the start of every single iteration. This lets us add every single value, positive, negative, to our curmax, move through the array, and at the start of every subsequent iteration, check whether we need to discard it or keep it.